Okay, good day everyone. My name is Shedrack and I'm here to teach you physics. We have syllables from SS1 to SS3. This is from SS1 work, fundamental and derived quantities. Now, what is fundamental quantities? We say that fundamental quantities is defined as the basic quantities that provide the basic units of measurement. It is the what? It is the basic quantity that provide the basic units of measurement. We say that it can also be defined as the quantities that is dependent of other quantities. Now let me explain. We say that fundamental means the basic of something. When somebody is telling you what is the fundamental of this, it means that this person is asking you what is the basic for this thing. That's also how it is in physics. When you are saying fundamental quantities, it simply means the basic unit upon which other unit what depends. Now let's go to fundamental units. We say that fundamental units are the basic units upon which other unit depends. Now you need to pay attention to this. It's very important because even in WAEC exam, this ask question. Example of the three most important fundamental quantities. There are three basic fundamental quantities, which are length, mass, and time. Which are what? Length, mass, and time. Now we have the standard unit of measurement. The standard unit of measurement are basically in meter kilogram per seconds. Meter kilogram per seconds or centimeter grams seconds. Centimeter gram second. Just watch what I'll show you. Okay, this is what I was trying to explain. It is in meter kilogram per seconds or centimeter gram per seconds. Do you get? It is either in meter kilogram per seconds or centimeter gram per seconds. These are the what? The standard unit of measurement. These are the now coming to know this standard unit of measurement to be meter kilogram per seconds or centimeter gram per seconds. What are the examples of fundamental quantities? We have many examples of fundamental quantities. If you watch from the note, you see plenty of them. If you watch from the note, you see plenty of them. From the note, you see plenty of them. Now we have one, time, and the SI unit of time is in seconds. We have length. The SI unit of length is in meter. We have mass. The SI unit of mass is kilogram. We have temperature. The SI unit of temperature is what? Kelvin. We have amount of substance. The SI unit of amount of substance is mole. Therefore, that is why you need to take this class seriously because we'll be taking you on step by step on everything you need to know in physics. Now again, we also have other examples of fundamental quantities. We have electrical currents. Under this electrical current, we have ampere as the SI unit. We also have luminous intensity. The SI unit is what? Candela. The magnetic flux, the SI unit is what? Weber. That is WB. Now, we have what we call fundamental units. What are fundamental units? We say that fundamental units are the basic units from which other units can be obtained. The unit by which other units can be obtained is what? Is fundamental unit. The quantity by which other quantities can be obtained is what? Fundamental quantity. I don't know if you are getting me. That is all about what we need to know under fundamental quantities. We'll be running down to derived quantities and units. Derived quantities and what? Units. Now, what is derived quantities? So that derived quantities are quantities obtained by combining two or more fundamental quantities. I seen it. For you to get derived quantity, as the name implies, derived simply means that you are getting it from somewhere. They are gotten from fundamental quantities, either by adding two or more fundamental quantities, you now have your derived quantities. I don't know if you are getting me. Okay. Please pay attention very well to this class. And make sure you are writing your note, because when I will check your note and your note is not complete, I will not be happy, because I'm taking time to take you on this class. Make sure as the note is as you are seeing the note, also make sure you are copying your note. Please, because you might ask me how we Sam mark our note. I will mark it. Yes, now mark it. That's what makes me a teacher, because I'm gonna check your note. While teaching in the class, I still go around to check whose note. I will also check your note one day. Yes. Now let's go to fundamental derived unit. It can also be defined as the quantity that is dependent on fundamental quantities. I see that derived quantities is dependent on what? Fundamental quantities. I don't know if you're getting me. Yes, I know you're getting me. If you have question, feel free to ask me. Now, let's also go to derived units. As the name implies, derived units. These derived units are obtained by combining two or more fundamental units by simple division or multiplication. I don't know if you are getting me. Now, we'll be going into examples of derived quantities. Now, this is here most students are finding it difficult, because they don't know formulas in physics. When you tell them to derive such this quantity or the other, they find it so difficult. Please, for you to know physics very well, this topic is very important, because it will teach you most of the formulas you need to know in physics. Most of them. Yeah, sure, I'm telling you. Now we have area. What is the formula for area? Length times breadth. And what is the SI unit of area? It's meter square. If you watch very now, you will see it. It's meter what? We say that the SI unit of area is what? Meter square. We have volume. And the SI unit of volume is what? Meter cube. Meter cube. M raised to the power 3 is the SI unit of volume. And what is the formula for volume? Length times breadth times height. We have density. Density, the formula for density is mass over volume. And the SI unit of density is kilogram per meter cube. I don't know if you're getting it. Please follow the class step by step. Yes, Now, we're also going to other examples of derived quantities. We have velocity. What is the formula for velocity? The displacement over time. Displacement over time. And the SI unit is meter per seconds. Meter per seconds. We have acceleration. What is the formula for acceleration? From what you are seeing from the blood, is velocity over time. And the SI unit of acceleration is meter per second square. Meter per second what? Square, from what you are seeing on the board. We have force. What is the SI unit of force? The SI unit of force is mass times acceleration. And the SI unit can either be in Newton or kilogram meter per seconds or kilogram meter per what? Seconds. Please make sure you go through the notes. I'm teaching you as if I'm seeing you. Don't think I'm not seeing you, because the Bible said that. Okay, let me don't go far. Let's continue. Now let's also work and energy. You need to also bear in mind that work and energy have the same unit and formula. What is the formula for work? Work is force times distance. Force times distance, and the SI unit is Newton meter or Newton meter square per second square, from what you're seeing. We also have another one, derived quantity as power. And the formula for power is work over time. And the SI unit is either Newton meter per seconds or kilogram meter square per seconds. We have for pressure, the SI unit of pressure is force over area. And the SI unit is what? Newton meter per square. Newton meter per square or kilogram per meter per second square. We have momentum. Momentum, when we talk about momentum, it's like two things coming together to jam. Momentum. When you say that somebody has momentum, it means that that person have strength. Like this person gather momentum, or means that person gather strength, that is it. We have mass times velocity is the formula for momentum. Sure. And the SI unit of momentum is kilogram meter per seconds. Another, the last one here, we have torque. And the SI unit of torque is force times distance. And the SI unit of torque is Newton meter. Please take notes. In most of the past questions, they will ask you which of the following have the same derive unit. Derive unit. One of the quantities or some of the quantities that have the same unit are majorly work, energy, and torque. Work, energy, and torque. Please, you need to also bear in mind that the derived quantities that have the same units are majorly work, energy, and torque. And torque is also known as moment of a force. Anywhere you see the word moment of a force, know that they are referring to what? Torque. Please take note of that. Okay, at this point, we have come to the end of today's class. We have come to the end of today's class. Remain blessed and make sure you go through the notes. In case if you want to contact me, my number is 070 40 43 6700. You can contact me, chat me up on WhatsApp. I will reply you. If you have any issue in physics, you can send message, I will reply you. But make sure you are following the class. Because if you're in SS1 and you start off following the class, you will see that before you get to SS3, you must have solved everything you need to know. And I'll be sending question. And please make sure you answer the question and send your your assignment for marking. I will mark it and also send back to you. Please, if I send assignment, make sure you do it. I remain the CEO of Top Success International Academy. I'm Obona Shedrack Chijindu. Remain blessed. Lastly, in our next class, I'll be taking your measurement and instrument. But this one we just looked at fundamental and derived quantities. Please follow the notes, make your notes, answer past questions. Thank you. See you next in our next class. I remain your coach in the person of Shedrack.